So as we know in last class, we discussed what is valency and as well as the types of valency. So we are having two types of valency. One is what it is, guys. One is electrovalency.
Electrovalency,
Covalence.
covalency.
So covalence in the sense of only by a number of sharing electrons, the shared pair of electrons. So electrovalency means in the sense of number of donating and as well as number of what? Donating and as well as number of accepting or receiving electrons.
Receiving electron.
Ionic compounds and the sharing of electrons will take place in covalent compounds. Is it yes or no? So this is all we have been studied in the last class. So as we know, ionic compounds will formed by what? A metal will donate electron to the non-metal so that non-metal will accept the electron so that it will form ionic compound. Is it yes or no? Please respond. So ionic compound always will form by one metal and one non-metal. Means one donor must be there and as well as one receiver or acceptor must be there. Then it will form ionic compound. Yes, Alana? Next. See, again exam is coming. Nobody should get less marks this time. Same way, it will take one non-metal with another non-metal. Both will share the electrons. Here, donating and receiving. Here, both are sharing the electrons. So this is only we used to called as covalent compounds. So now similar way, if it comes to here, metal plus metal, if you take, no compound will form. Why? Both are donors only, so no reaction will take place. Is it okay, guys? So we have two kinds of compounds. One is metal plus non-metal, ionic compounds, and as well as non-metal plus non-metal, we used to call as covalent compounds. This is what you people need to remember. So now if you notice it, Darun, Monesh and all not there, Sira. Aswida, inform Mani and Samya. Mahalakshmi, are you there? So now if you notice it, yes. So now if you notice it, no compounds will formed by metals and metals. And these are all the things we have been studied. So simple definition of valency. What do you mean by valency? We can say the combining capacity.
Combining capacity.
So combining capacity is only called as valence. Understand? So anything if you take. So it may be combining capacity of any element. Combining capacity of an element is called as valence. So this valence, how it will vary is one element may donate one electron. Some elements can donate 2 electrons. Some elements can donate 3 electrons. Some elements can share 4 electrons. Some elements can accept 3 electrons. Some elements can accept 2 electrons. Some elements can accept 1 electron. Some elements does not accept any electron. So this is what how valency is increases and how valency is decreases. Yes or no, guys? So +1, +2, +3 positive valency means donors and 4 what? 4 it is what? It is sharing electron. -3, -2, -1 is receiving electrons and zero is a what? Zero valence. Understand? Means neither donating nor receiving. Yes or no? That is what you have to remember it. So now if you understand this, then we will proceed. Today's class, we are going to study the next concept is very, very important. From this, definitely in exam, one question surely will come down. So be very careful. So as we know, first of all, before going to start that concept, first of all, let us once again revise. So we know that every atom, every element is containing some number of atoms. Yes or no, guys? Some are monoatomic. That is what we used to call as atomicity. What we used to call? Atomicity. So now, atomicity means the total number of atoms made up of, means how many atoms are present in an element of a molecule of one element is only called as atomicity. So if you take for example, once again I will say, observe the total number of atoms present in one molecule of an element is only called as atomicity. What was to call? Atomicity. So now if you take Monoatomicity, first example, types of atomicity. So monoatomicity, if we'll take, so means in the sense of how many atoms are present. If we'll take elements, so for
One
example,
atom.
we'll take
One
potassium,
atom.
sodium, calcium. So these all are, this is called as what? Elements only. Is it yes or no, guys? But how many atoms we are writing? Only one
Yes,
atom
sir.
itself. Understanding? One atom itself we used to call it as molecule of an atom, element. So these kind of atoms, atomicity is one. Understand, Alana, Laksha? Everybody? So this is what you have to understand. So the elements which is having, understand, which is forming, one atom itself is forming molecule of an any element, then that is called as monoatomicity. What we used to call it? Monoatomicity. Understand?
Monoatomicity.
What do you mean by atomicity? The number of atoms forming the molecule of an one element. Understand? Molecule of an element is only called as atomicity. So now, second one, if we take
Atomicity.
diatomicity, what we used to call? Diatomicity. So di indicate what? Di indicate what, guys? You might be understand di
Two.
indicate. What is
Two.
that? Two. Understanding means two atoms
sir.
of an element. Understanding two atoms are combining together to form a what? To form a molecule of an element. Understanding molecule of an element, then that is called as diatomicity. So now if you take for example all the gases, hydrogen, one atom cannot exist together. So two hydrogen atoms can exist together. So that is why whenever we are writing hydrogen gas, we'll write what, guys? H2 we will write hydrogen gas. Same way if we take chlorine. One atom of chlorine cannot survive, and that is why it is combined with another chlorine atom. So that is why what is the atomicity of chlorine, guys? Diatomicity. What is that?
Cl2.
Diatomicity. Same way if we'll take oxygen, so two oxygen molecules is together, so atomicity is 2. So same way if we'll take fluorine, so fluorine also two fluorine atoms, it is F2. So if we'll take nitrogen also, so two nitrogens will be together, so that is why we'll write N2. So like this, if we'll take bromine, so Br and Br, so two it is together Br2. Like that, all the gases which they are forming, because they cannot exist, single atom cannot exist independently. So that is why it will combine with another atom and it will form atomicity. Understand? That is what they used to call as diatomic molecules. What we used to call diatomic molecules, and they are called as what is that called as diatomicity. Understand, everyone? Yes, please respond. So that is what everybody
Yes,
need to
sir.
remember. So what do you mean by atomicity? So some elements will formed by single atom. Some elements will formed by two atoms. Some elements will formed by three atoms together. For example, if you can take triatomicity, what is this? Triatomicity. So now you might be know that a protective layer which is protect our atmosphere. What is that called as, Mukesh Karthik Shakti? What is it called as?
Ozone, sir.
Ozone.
Ozone.
So ozone. So if you notice it, ozone is a triatomic molecule, means three oxygen molecules is together. Then it is called ozone, O3. So that is why it is called as, you might be see, ozone is one of the compound or element. So the molecule of a ozone is formed by three oxygen atoms are combined together. So that is why it is called as triatomicity. So if we'll take like this, more than three, we used to call it as more than three. Understanding? So number of atoms is greater than three, we used to call it as polyatomicity.
Polyatomic.
Polyatomicity. So if you take, so for example, phosphorus. So phosphorus always, how many atoms are there? 4 phosphorus atoms will come together, and then only it can exist together. So like that, if you take sulfur, so sulfur, 8 atoms can combine together. Understanding? So imagine then how many? So 8 atoms, just for example, I'm saying class 10th, you will study the structure also. So 8 atoms together. So this is what we used to call as, understanding? So octatomicity, but we can say more than 3, what we used to call, Shruti? More than 3 we used to call as polyatomicity. Understand? So examples you can take P4 phosphorus and sulfur, S8. That is what in second chapter also you might be see. Calculate the atomic mass of S8 means we have been multiplied 8 into 32. Do you remember, Pradosh? We have been done atomic mass of sulfur. So
Yes,
that
sir.
is plus each sulfur is having what is the atomic mass? 32 into 8 we can take. That is what will give you the total atomic mass of molecule. Yes, Aswita, Elmokil, everybody, called
Yes,
one
sir.
and Sai,
Yes, sir.
Darun, that is. So now if you notice it, this is what you have to understand. What do you mean by atomicity? So if you'll say, what do you mean by atomicity? Simply the number of atoms forming the molecule of any element is only known as atomicity. If single atom itself will form, it is monoatomicity. If two atoms is forming molecule, then it is diatomicity. Now more than two atoms is forming, it is called as what, guys? It is called as triatomicity. Understand, Ra? Please respond. More than three, we used to call it as polyatomicity.
Polyatomic.
Yeah, if it is three, triatomicity we can call, but common name after three we used to call it as polyatomicity. Understand, everybody, Pradosh? So now if you'll come to the again, so let it be some atoms may be made up of some elements may be made up of one atom, some elements may be made up of two atoms, means molecules, some elements molecules made up of three or more than three also. But if you take every atom it contains three subatomic particles. What is that? Can anybody say? Anyone? What is that
A
particle?
neutron, proton, electron.
As we know, we'll consider. So then the center is only ways to called as. What is this called as, guys? The center is called as
Nucleus.
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 So nucleus, and the present is called as nucleons. So the nucleons is only called as what? Protons plus neutrons.
Neutrons.
And as well as and the outer shells, energy levels, who is revolving? Electrons are revolving. Electrons are revolving. Yes or no? So now if you notice it, it's okay, Laksha. So now if you notice it very carefully, observe very carefully. So for every element, something is constant. Can anyone say who is that? Already we studied two things, mass number and atomic number, or else atomic number and atomic mass. Can anybody say? So atomic number, what do you mean by atomic number? Elmokil, atomic number, Sai.
Number of protons.
So number of protons, yes or no? Yes, number of protons, and as I told you, for every atom, number of protons is equals to what? Number of protons is equals to something. What is that? Number of
Number of electrons.
We are not saying number of atomic number means number of electrons, because they are involving in chemical reaction. So that is why you might get confused with the atoms and ions. That is why we will say number of protons is used to called as atomic number. Yes or no? Yes, that
Yes,
is. You know, also you can say, so atomic number we used to represent with what? Atomic number is it atomic number is going to change every time? Whatever it is,
Okay.
atomic number does not change. So which we used to represent with the Z. Okay.
That's
Number of protons for a particular atom, element of a particular atom does not changes every time. Whatever it is not going to be changed at all. So it is always constant. Understand, Shakti, Adarshan? So who is constant always? Atomic number means in the sense of what? Number of protons of any element, atom of any element remains constant. Now, as we know, mass number. What do you mean by mass number, guys? Mass number, or you can take, also we can call it as what? Also we can call it as atomic number, atomic mass. Atomic mass or mass number if you take, which is equals to what? Number of
proton plus number of neutrons.
Yes. Tell me, guys. Number of
neutrons.
neutrons. So as we know, mass of one proton we used to consider 1 U, and mass of one neutron also we used to consider what? 1 U. So that number mass, atomic mass we used to represent with what? Atomic mass or mass number A, which is equals to number of protons plus number of neutrons. So number of protons only we used to call it as what? atomic number is Z,
Atomic number.
atomic neutron. So this is what the relation we have been found in the last class. Yes or no? Already we have been
Yes, sir.
studying. Yes?
Yes, sir.
Shruti, Vanya and Samaya, have you understand Devarsini? So now if you notice it here, so let us take, so in our today's class, from this you have to understand that always who is remains constant, Laksha, Sai, who is remains constant always?
Atomic number.
Number of protons, or we can say atomic number
of protons.
remains always constant. So now in our today's class, we are going to study the next concept is called as isotopes. What is that? Isotopes. So observe very carefully. See, in future again other names will come. By the time we should not, because isotopes, isobars, isotones, understanding like this different things used to come in a higher classes again in same chemistry only. So that is why you are not supposed to get confused with it. So what do you mean by isotopes means? Observe. Most of the elements in our surroundings. So every element is made up of what? Elmukil, Maitreyan, every element is made up of what? So we are having so many elements in our surroundings. Yes or no? Please respond. So different
Yes,
kinds of elements we used to present. This is one element, this is one element, this is one element. So every element is made up of what? Every element is made up
Atoms.
of
An atom.
yes or no? So now remember, so if we'll consider number of atoms which have a same atomic number but different mass number. So such an atoms of an element is to called as isotopes. For example, let me take this is one element. So let me erase this one and again draw. So now I am erasing this one. I am considering atoms of an same element. Do you understand? So let me consider this is one element and this is also what? Same element. Do you understand? Both are what? Same element. And here also what? Same element. So same element means somebody is constant. Who is that, guys? Atomic number.
Atomic number.
So atomic number is constant. And here also atomic number is constant. So it is made up of what? It is made up of atoms and it is also made up of what? Atoms. So here, if you notice it, same elements, understanding, same element, the atoms of the same elements, if we consider, the atomic number is constant, but mass number or atomic mass is not what? Is not constant. So here also is not constant. So like these atoms of an element is called as, what we used to call? What we used to call, guys? Isotopes. Understand? So the elements, the atoms of an element whose atomic number is constant and mass number is not constant, what we used to call it as Shakti? We used to call it as isotopes. Understand everybody? So isotopes are the atoms of a same element or different element? Brothers? Same element.
Atoms of same element.
Same atomic number but different mass number or different atomic mass. That is what we used to call as isotopes. So isotopes of an element have the same atomic number, means in the sense of who is constant, they contains same number of protons. Understanding? They contains what? Same number of what, guys? Same number of protons and same number of protons. So protons is same means who is constant? Electrons also same. Yes or no? But only mass number is changing means only number of neutrons varies. Who is varies? Number of
Neutrons.
varies between the atoms of same element. So this is what is causing for change in its atomic mass, or we can say mass number. Purima, everybody clear? So isotopes of any element, we can say they're having same atomic number, means in the sense of what? Same number of protons but different mass number because they contains different number of neutrons. Understand? So based upon number of neutrons, atom character cannot decide. Only who will decide the character of an atom? Everybody?
Number of protons.
Only number of
Protons.
Understanding? So neutrons may be high or low, doesn't matter. So from that we can say the isotopes of an element differ in their whom, guys? Only differ in the number of isotopes of an element. Who is
Neutrons.
difference and where?
Neutron.
Difference in
Neutrons.
number of neutrons in their where they are located. They are located in
Nucleus.
nuclei. Understanding. So now we'll explain with the example also. First of all, have you understand what do you mean by isotopes? Laksha, Mahalakshmi,
Yes, sir.
everybody. Right. So isotopes are atoms, right? Isotopes are atoms of the same element. Isotopes are the atoms of the same element. Isotopes are the atoms of the same element. Darun not yet joined. Darun is having school. I don't think so. For those who is missing, Darun alone, any other? Sai is there? Sai is there.
Yes, sir.
Darun.
Okay, just call to Darun. Right. So have you understand? Laksha, what do you mean by isotopes? Aswita, Manya and Samaya? Right. So isotopes means what? Same atomic number, different mass number.
Same
That is,
atomic number, different atomic.
that is right. Isotopes are atoms of the same element. Atoms of the same element having same atomic number. Having same atomic number. Same atomic number means who is constant, Ramonesh? Same atomic number means
Proton.
same number of protons. Bracket you can say number of protons.
Proton.
Number of protons. Same atomic number. Same atomic number. But different mass number. But different mass number. So bracket what you can write? Differ in number of neutrons. Differ in mass number. Differ in what? Mukesh Karde? Differ in number of neutrons. So neutrons are present in where? Nuclei. That is nuclei. That is what we used to call as nuclei. That is. So this is only we used to call as isotopes. Okay. So now we can say example. Let us take example. So now the best example, well-known example is, we already people know that what is the chlorine atomic number? Everybody tell me. Chlorine atomic number is what? 17. Yes or no? Now, and also we have been studying chlorine atomic mass is, which is equals to what? 35.5 U.
35.5.
5.5.
35.5 U. Yes or no? Asita. So now if you notice it, sir, how you can say it is 35.5 U? So let us go. So now also remember, in any atom, no half proton is present. Do you understand everybody what I'm saying? No half neutron is present to get half. Do you understand what I'm saying? Everybody? So always the number of protons and neutrons present in any atom will be a whole number. Do you understand? Will be a whole number. It will never be a fraction or ratio. That is what you have to remember always. Okay. So now if you notice it very carefully. So now for example, if you take chlorine. So chlorine. So two kinds of atoms we can find in chlorine. One is chlorine 1735 and chlorine 1737. Chlorine 1737. So have you noticed it? Two are atomic number is same. What is the atomic number of chlorine? Chlorine.
17.
Please respond. 17. So now what is the mass number? What is the mass number, guys? Mass number, how much it is? 1 time 37. So now, sir, where it will vary? Let us write. So if we'll take chlorine 1735. So first of all, let us go with the number of protons. Next one, number of neutrons. Next one, number of electrons. So as we know, for every atom, number of protons plus number of protons is equals to what? Number of electrons. Yes or no? So now, as we know, atomic number is equals to protons. Yes, guys, please respond. So how many protons are there? How many protons?
17 protons.
17 protons. So electrons also how many? Electrons also 17. Now,
70.
35 minus 17 if you take, which is equals to how many neutrons?
18.
18 neutrons are there. In first case, 18 neutrons are there. So now second case go 17, 37. Now if you take number of protons again, how many, guys? Number of protons are 17. Number of electrons are 17. So now 37 minus 17. How much, Ra? 37 minus 17.
20.
is
20.
equals to 20. So who varies here? Have you noticed it? Same atomic number, but
Mass neutron.
number of neutrons. This is only we used to call as what we used to call isotopes. What we used to call isotopes. Understand, Jayavarsini? So now, sir, then how you found 35.5? 35.5. So that is what we are going to use one formula again here. Remember, in our atmosphere, definitely for everything percentage, for how much percentage we will calculate always, which is equals to 100 percentage. Yes or no?
100%.
Yes. Generally in mathematics, we will calculate the percentage for equals to 100. Yes or no, guys? Will you accept it? Now, if we'll take in our surroundings, these kind of chlorine atoms is present in some percentage, and these kind of chlorine atoms is present in some other percentage. So based upon this percentage only, we will find the average atomic mass. So mass number now will become what? So mass number, we won't say for isotopes. So mass number for isotopes, what we used to call? Isotopes is called as average atomic mass. What is that? Average atomic mass. So that is also represent with the A only. What we can represent? A only we used to represent. Is it okay now, everybody? So now, if we'll take this one, so now the average atomic mass, how we can find means in the sense of, so we'll use a formula. So that is what used to be, UN used to call calculated. That is a percentage of first element. What is that? A percentage of first atoms plus the percentage of second atoms, if you take, then which we used to get the average atomic mass we used to get. So now, for example, let us take the chlorine. So now if we'll take, so what is the formula to calculate average atomic mass for any element you can take? First of all, you have to write atomic mass of first isotope. What we used to call? Atomic mass of first isotope. Understand, Ra? Isotope into percentage of first isotope. Percentage of first isotope. Understand, Elmukel? Sai? Atomic mass of first isotope into percentage of first isotope plus, suppose, see, if you take chlorine, this is called as first isotope. What we used to call? First, tell me, isotope. Now this is called as what? Second isotope.
Second isotope.
So now what I'm saying the formula, atomic mass of first isotope into what it is? Atomic mass of first isotope into percentage of abundance. That is what we used to call as percentage of abundance. Means what we used to call how much it is existed in this nature. How much it is existed in this nature is only called as abundance, we used to say. So now similar way, if you notice it, the second isotope is also present. So what we used to come? Anybody can tell me? Atomic mass of what will come? Second isotope. Isotope into percentage of
second isotope.
So that is only we used to called as abundance. So what do you mean by abundance? Existed. How much percentage is existed? For example, if we take oxygen, what is the percentage in atmosphere? 21 percentage. Yes or no? Nitrogen, if we take 78 percentage. This is only we used to call as abundance. What we used to call? Abundance. How much percentage is present? So this is what the formula for calculating average atomic mass. For example, third isotope is there. How it will come formula? If third isotope also present, what will come? Atomic mass of third isotope into percentage of third
percentage of abundance.
Now, let us take now chlorine. So if we take chlorine, we have two kinds of isotopes. What is the isotopes of chlorine, everybody? Chlorine 1735, chlorine 1735, and as well as chlorine 17 what, guys? 1737. Yes or no, Jayavarsini? Yes, please respond. So now if you notice it,
I want to divide it by 100, no, sir.
Yes. So all the
I want to divide it by 100, no, sir.
Yeah, that is what percentage we are writing. Do you understand? So now if you notice it, basically, so this 35 mass number, this is present in our atmosphere, basically 75%. What is this present? 75% of abundance, and this is 100 minus 75, which is equals to how much? 25% is the abundance. So now we are going to find average atomic mass of chlorine. What is that? Average atomic mass of chlorine. So now let us see. So chlorine you can take. What is atomic mass? First formula. Atomic mass is how much? 35 into percentage of abundance. How much, Pradosh? 75%.
25%.
Atomic mass of 37 into percentage of abundance 25. So now if we'll take, which is equals to 35 into 75 by 100 plus 37 into 25 by 100. Is it okay, Almokil, now? Are you clear? That is. Now, if we'll multiply 35 into 75, how much it will come? 2625 will come. Is it yes or no? Everybody do it.
625.
2625 divided by 100 plus same way this one 37 into 25, how much it will come? 925 will come. Check it, everybody. 925 divided by 100. Is it okay? So now we can do the division. How much it will come? 26.25. Yes or no?
26.25.
Yeah, 26.25.
9.25.
This is 9.25. So now if you add this two, we used to get how much? 35.5 U. So this is what? Average atomic mass of chlorine. So like this only we people used to get the average atomic mass of chlorine. Is it okay, everybody? Shruti, Manya and Samaya, Adarshan?
Yes, sir.
That is what you have to understand. Alana, are you understand, Alana? So what is the formula for calculating average atomic mass? Atomic mass of first isotope into percentage of first isotope plus atomic mass of second isotope into percentage of second isotope. If third isotope is there, third isotope is also coming in the same manner. So that is what, see, one question surely will come in the exam. If my guess is true, this is only maybe they may ask, or else they maybe give you average atomic mass and they will ask you to find the abundance. If that similar question is there in our exercise, I think 12th question, bromine and iodine. Anyhow, I will teach the
Yes,
exercise.
sir.
11th question.
Yeah, 11th question, bromine and iodine question. So that exercise also I will teach you. So by that time, you people can understand more nicely. So this is the first thing. So calculate average atomic mass of chlorine, 35.5. How it came, have you understand now, everybody? Yes? That is.
Sir.
Yes, sir.
So now, if I have
Sir.
done, yes, please. So, but you cannot say the number of isotopes are same for every atom. Understand? So now if you take, for example, hydrogen, as we know. So the number of isotopes are how many for hydrogen? 3 isotopes are present. So please all of you write hydrogen. So next, isotopes of hydrogen. Isotopes of hydrogen. Isotopes of hydrogen. Chlorine, have you did, guys? Isotopes of hydrogen. First of all, finish chlorine, then only I will go to hydrogen. Chlorine, have you completed? You tell me, then only I will go to hydrogen.
Yes, sir.
Everybody do it. Aswita, Sai. Completed? Now, isotopes of hydrogen, if we'll take, so isotopes of hydrogens, where we know that how many isotopes are there? 3 isotopes are there. Is it yes or no? So 3 isotopes. So first one is hydrogen 1,1. Second one is hydrogen 1,2. Third one is hydrogen 1,3. Everybody. Yes, these are the three isotopes we have. So now first isotope, if we'll take, for example, isotopes of first one. So first one we used to call it as what? Proteome we used to call it as. What is the first one is called as? Proteome. A simple hydrogen. or else we can say, understanding, a light hydrogen, light or less weight hydrogen. See, this is called as heavy hydrogen and this is called as light hydrogen. So this is what we used to call as proteome. So now if you take proteome, so number of protons, number of neutrons, number of electrons. So number of protons, how many guys? 1. Number of neutrons? 0.
1,
Neutrons also
0.
0,
the protein will come. Deuterium, understanding? Deuterium we can say. So
Deuterium.
deuterium. So deuterium. 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 So if you take number of protons, how many? 1. Number of neutrons also 1 - 1, and the number of electrons also 1. So that is last one. Heavy hydrogen we used to call as tritium. What we used to call? Tritium. So in this question will come surely. So number of protons here also, how many girls? Number of protons in tritium? 1. Number of protons are 1. So now 3 minus 1. Number of neutrons are how many? Number of neutrons are
2.
please respond 2. And number of electrons are 1. So this is what is called as isotopes. Yes or no? Isotopes. So hydrogen is having